Afternoon. Hope you all are very safe and you are using your free time properly for the full preparation of coming exam. And I hope you will get the very good marks and you will maintain the reputation of Boulevard higher secondary school. And today I am going to discuss two very important long questions. One is from the first chapter of modern physics, that is J.J Thomson experiment. And this experiment is for the determination of specific charge of electron. And another is helium-neon laser, very, very important long question. And these two are a little bit problematic for students. That's why I chose these two questions only, and I'll try to explain properly and very slowly so that you can grab all the subject matter properly. Sir, मैं discover यहाँ जो like ठीक ठाक sir. Okay, then first. Let me discuss first question. That is J.J Thomson experiment for the determination of a specific charge of an electron. The specific charge is defined as the ratio of charge to mass. Charge of electron divided by mass of the electron is the specific charge of electron, and its value is 1.76 into 10 to the power 11 coulomb per kg. And then this experiment is explained on the three category. First one is principle, second one is construction, and third one is working. And this question is for this topic is 4 marks question, and you have to explain, you have to write properly. And then look, first topic is principle. Principle of this topic is the study of motion of a beam of electrons in cross fields. Study of motion of electrons in cross fields, that is electric field and magnetic field perpendicular to each other. The principle of this experiment is to study the motion of beam of electrons in cross fields, that is electric and magnetic fields perpendicular to each other. Then next one is yes. This one is construction of J.J Thomson experiment. This one, and look, it consists of this figure shows the simple diagram of this J.J Thomson experiment to determine the specific charge of electron. It consists of a highly evacuated tube, and which contains a cathode C, which emits electrons, and anode A, and an accelerating potential V is applied. Accelerating potential V is applied between cathode C and anode A, so that the emitted electrons are accelerated toward the anode A. The anode A has a fine central hole, so that a fine beam of electrons emerges through it. Now the beam of electrons enters into cross field, represented by dotted circle for the magnetic field, and electric field is applied between the plates P and Q, making upper plate A positive, upper plate P positive. The tube has a screen XY, XY, and the screen is coated with fluorescent substance like zinc sulfide or barium platinocyanide, so that when the beam of electrons hit it, a luminous glow is produced on it. Let me briefly repeat the construction of this experiment. The figure shows the experimental arrangement, and it consists of a highly evacuated tube which contains cathode C and anode A. And an accelerating potential is a potential of voltage V is applied between cathode C and anode A, so that electrons are accelerated toward the anode A. The anode A has a fine central hole, so that a fine beam of electron emerges through it. Now the beam of electrons enters into cross fields. The dotted circle represents magnetic field, and here magnetic field is perpendicular to the plane and directed inward, and electric field is applied between the plates P and Q, making upper plate P positive. And it has a screen XY coated with fluorescent substance like zinc sulfide or barium platinocyanide, so that when a beam of electrons bombard it, a luminous glow is produced on it. Now, let's go to the theory or working. Next one is working. Here, the electron, this topic has two methods. One is a little bit lengthy, but another is short and sweet, and I chose short and sweet. And this one here, in this simple method, electrons are accelerated toward the anode A by an accelerating potential, and then this look, if BB the accelerating potential between the cathode C and anode A, then electrons will have potential energy at the cathode C, and that converts into the kinetic energy at anode A. So therefore, from the principle of conservation of energy, kinetic energy at Ke, kinetic energy of electron at the anode must be equal to potential energy of the electron at the cathode C. So K equal to PV. K means half mv square, and which is equal to the potential energy E times V. So we can simplify it. E by m, which is the specific charge of electron. So E by m equal to half V square, velocity square by potential capital V. Here be careful, small b is for potential and capital V for voltage, accelerating voltage. There are two types of voltage. One is accelerating, another is deflecting, and this potential is the accelerating voltage. Let me repeat this theory one time. Theory, or we can say working. When the electric field is applied, the beam of electrons are accelerated toward the anode A, and the if be the potential accelerating potential, then potential energy of electron at the cathode C is EV, and that kinetic that potential energy is converted into kinetic energy, kinetic energy, okay, which is equal to half mv square. So K equal to PE, kinetic energy equal to potential energy. Kinetic energy means half mv square equal to potential energy equal to EV. So E by m equal to half V square, velocity square by V, voltage. If we are able to measure the velocity of electron, then we can easily calculate this specific charge of the electron, specific charge of the electron. Now, if the beam if the beam of electron enters only in the electric field, it deflects toward the positive plate, and in our case the upper plate is made positive, so electron deflects on the upper plate upper plate deflects toward the upper plate and produces a luminous glow S1. You can see in that this S1 in the diagram. And if magnetic field, if we apply only the magnetic field, and then electron deflects in the downward, that is that you can apply, you can use Fleming's left hand rule, and then with that rule you can easily say the beam of electron deflects downward and produces the luminous glow S2. Now both fields, electric and magnetic fields, are applied simultaneously, and their values are adjusted so that the net force on the beam of electron just becomes zero. Net force due to electric field and magnetic field just becomes zero. In that situation, Fm will be equal to Fe, and the beam of electron moves in a straight line and produces a luminous glow, central luminous glow S. So Fm equal to Fe. Fm, the magnetic force of the electron, if B the magnetic field is strength, so B into E into V, velocity V, BeV, Fleming's left hand rule, you know, this is the magnetic force of electron is equal to electric force of the electron EE. Here E the charge of electron, B the velocity of electron, small v velocity of electron, and capital E the electric field strength. Then small v equal to E by B. So by measuring electric field, this electric field is the deflecting electric field applied between the plates P and Q, and you can easily calculate, because capital E equal to voltage upon voltage divided by distance, E equal to voltage, that voltage applied between P and Q, and the distance between P and Q. And B, and capital B is the magnetic field strength. So velocity V equal to E by B. And if we substitute the value of a small v in equation 2, we get E by m equal to half E squared upon V into B. We know we can easily calculate electric field. This one is the deflecting electric field. Capital E means deflecting electric field, and a capital V is the accelerating potential between cathode C and anode A, and B is the magnetic flux density and magnetic flux strength, the magnetic field strength, we can say, and all values are known. Now we will get in the conclusion. Conclusion is the specific charge of electron is 1.76 into 10 to the power 11 coulomb per kg. And in this is in three significant figure. In two significant figure, this value is only 1.8 into 10 to the power 11 coulomb per kg. Okay. In this way, this question is over, and then let me briefly explain again this one. Look, and then I'll go to next question. This J.J. Thomson experiment is very, very important for a long question, and in the exam you must make very nice diagram, very nice clear diagram, and no need to write lengthy paragraph on that construction. Okay, simple one paragraph, short and sweet paragraph will be the best on the construction. Okay, and before that you have to write, first you must write principle. Here I'll show you its format. Look, first you must write principle. What is the principle of this experiment? Hope you know. That is to study the motion of beam of electrons in cross fields. That is, the electric field and magnetic field applied perpendicular to each other. Yeah, look, this principle of this experiment is to study the motion of beam of electrons in cross fields, that is, electric field and magnetic field perpendicular to each other. So that deflection produced by one field is just opposite of another field. And then construction, here is the construction, a construction of this figure. Here, let me go. This one, size, it's not appropriate, little bit, it went out of scale. So here, this figure shows it's a simple experimental arrangement of J.J. Thomson experiment to determine the specific charge of electron. It consists of a highly evacuated tube, this one highly evacuated tube, and which contains a cathode C and anode A. This is cathode C. Hope you see this one is cathode C, and this is anode A. And an accelerating potential is applied between the cathode C and anode A, and its value is capital V here in this figure, and the emitted electrons are accelerated toward the anode A by this accelerating potential, and the anode A has fine central hole, and so that a fine beam of electrons emerges through it. Now the beam of electron enters into cross fields. In the cross fields we know electric field and magnetic field must be there. This dotted circle represents magnetic field, and this electric field is applied between the plates P and Q, making upper plate P positive. Here the magnetic field is perpendicular to the plane and directed inward. So upper plate P is made positive. And XY is the screen which is coated with, here Y is not seen, but down here is Y, XY is screen and this screen is coated with fluorescent substance, so that when a beam of electrons bombard it, a luminous glow is produced on it. Okay, then next will be this one is for the construction, screen XY, and next one side, this one is for working. Electrons are accelerated by an accelerating potential toward the anode A, and if V volts is applied between the cathode C and anode A, then electrons of potential energy is converted into the kinetic energy when they arrive in the anode A. So K equal to PE. Kinetic energy is half mv square equal to E into V, potential energy. And we have to simplify it for specific charge E by M, E upon M equal to V square upon half into V square upon capital V. Small v is velocity of electron and capital V is potential, accelerating potential, not deflecting potential. Okay, look, if the beam of electron enters only in the electric field, and then the beam of electrons deflects toward the positive plate, and luminous glow S1 is produced. And when the beam of electrons enters only in the magnetic field, then it deflects in the downward direction, and luminous glow S2 is produced. Now both fields, electric and magnetic fields, are applied simultaneously, and their values are adjusted so that the net force on the beam of electron just becomes zero. In that situation, the beam of electron enters, moves in a straight line and produces central glow as in the screen. Here, Fm equal to Fe. Now let's go, and then you know, if B is the magnetic field strength and E the electric field strength between the plates P and Q, then magnetic force BV must be equal to electric force EE. This one, and then B equal to E by B, electric field E divided by magnetic field B. Then we will substitute this value V in equation 2, and we get E by M. Okay. Now we know the value of E. This is the electric field strength between the plates P and Q, and we know accelerating voltage capital V, and we can easily measure the magnetic field strength with a flux meter. So we can easily calculate magnetic this specific charge of electron, and its value is E by M equal to 1.76 into 10 to the power 11 coulomb per kg. This is a universal value. Okay, let me go to the next question, next topic, that is helium-neon laser. Yeah. Let me open another topic. Just wait 1 minute. I have to open another. Next one is here. Recent find helium-neon laser. This one must be good. Same, but here first part I same as previous, but same. Here I'll discuss helium-neon laser. This is another very important long question you all are familiar. This is a little bit difficult and its explanation is different in different books. So I chose this topic thinking that you will be benefited from this class. And you know, laser means light amplification by stimulated emission of radiation. And I will also explain this this question in three subtopic. First one will be construction, second one will be energy level diagram, and third one will be working. Yeah. First one is this shows simple diagram of helium-neon laser. I made with freehand, so diagram may not be very good, but you can see properly each and every part. And this figure shows the schematic diagram of helium-neon laser. It consists of a highly evacuated tube T. It consists of a glass tube. This is a glass tube T. Tube T, and it contains, this tube contains, here let me repeat the sentence. This figure shows the schematic diagram of helium-neon laser. It consists of a uniform bore glass tube T, which contains a mixture of helium and neon, and the ratio of 1:4. Helium must be 4 times and neon must be 1 time. 4:1 or 5:1, 9:1, 12:1, 15:1, depending on the power of the laser. Let me repeat there. It consists of a uniform bore glass tube T, which contains a mixture of helium and neon in the ratio of let's say 9:1 or 5:1, 10:1, 15:1 at reduced pressure. The ratio varies according to the power of the lens. And there are 2 mirrors, M1 and M2, at the end of the tube. The mirror M1 is 100% reflective. Mirror M1 is 100% reflective, and mirror M2 is about 95% reflective. Let me repeat this part. Figure shows a simple diagram of helium-neon laser. It consists of a uniform bore glass tube T, which contains a mixture of helium and neon at the reduced pressure in the ratio of 5:1 or 9:1. There are 2 mirrors, M1 and M2, at the end of the tube. The mirror M1 is almost 100% reflective, and mirror M2 is almost 95% reflective, and laser beam is emitted through the mirror M2. There are 2 electrodes in the tube to maintain the electric field and this mixture of gas. Let me repeat. It consists of a uniform bore glass tube T, which contains a mixture of helium and neon in the ratio of 4:1 or 5:1, 9:1 at reduced pressure of about 1 mm of Hg. Why do we need reduced pressure? You know, without at normal pressure, electric discharge does not take place, and gas will be the insulator for the electricity. And okay, that part must not write that one only. Only you should write the ratio of mixer. Okay, in the ratio of 5:1, 9:1 at reduced pressure. The mirror M1 is almost 100% reflective, and laser light will not be emitted through it, and mercury is almost 95% reflective, and laser beam is emitted through it. There are two electrodes in the tube to maintain the electric field in the mixture of the gas. That much will be enough for the construction. Let me go to the energy level diagram. This is the energy level diagram of helium-neon laser. Sorry. This is the energy level diagram of helium-neon laser. And helium atom has metastable state twice S, having energy 20.61 electron volt. But helium atom has a metastable state twice S, having energy 20.61 eV, electron volt, which is very near to the 20.66 electron volt of neon atom. This is a 5s state of neon atom, and it has another lower energy level. It for energy level, and it's 3p, and its value is 18.70 eV, electron volt, 18.70 electron volt. Lasing action takes place between this 5s and 3p of neon atom, and laser light is laser light photon is produced, and we can easily calculate its wavelength by using the simple formula Sc by lambda, Sc as Planck's constant, C velocity of light upon wavelength equal to energy difference of E5s minus E3p, and we will get 632.8 nanometer laser light, which is red laser light. Any problem? Look, the next one, look, this one, next, I want to show you this one, and then working of, let me repeat the energy level diagram one time, and I will go to the working. Figure shows the relevant energy level diagram of helium and neon atoms. Helium atom has metastable state 2s, having energy 20.61 electron volt, which is very near to 20.66 electron volt of neon atom, and this is 5s state. And then helium atom has another energy level. There are other, but we'll consider only this one. This is 3p energy state, having energy 18.70 eV, and lasing action takes place between this 5s and 3p of neon atom, and laser light. This is laser light of wavelength 632.8 nanometer, or 6,328 angstrom, same thing, is emitted, and we can easily calculate its wavelength by using the formula also, Sc by lambda, Sc upon lambda, wavelength lambda equal to energy difference, this E5s minus E3p, and we can calculate this value. Okay, then working. Okay, third part, working. Now, when the electric field is switched on, when the electric field, let me go here. When electric field is switched on, then what happens? Electric field is applied. This electric field is applied in the mixture of gas, and free the electrons are ions are accelerated by this field, and this accelerated, when this accelerated electron bombards helium atom, the energy of energy of helium energy of electron is transferred to the helium atom. Let me repeat that one. The accelerated electron, let me go again here. See this one. The electric field is switched on and electrons are accelerated. The accelerated electron gets collided with helium atom and its energy is transferred to the helium atom, and helium atom goes to the metastable state twice as, and electron comes to the rest, and which is again accelerated by the electric field. Electric field is switched on, and then what happens? Then electrons are accelerated by the electric field. The accelerated electron gets collided. This accelerated electron gets collided with this helium atom. Why only helium? Why not neon? Hope you know its answer, because helium is 4 times greater than that of neon atom. Okay, and then this helium atom electron gets collided with helium atom, and electron's energy is transferred to the helium atom, and helium atom goes to the metastable state 2s, having energy 20.61 eV. This energy is nearly equal to what? And then 20.66 electron volt of neon atom. So when the normal neon atom gets collided with helium atom, what happens? Helium atom's energy is transferred to the what? Helium atom energy is transferred to the neon atom, and neon atom goes to the excited state 5s. It is also metastable state 5s, and helium atom comes to the ground state. This process goes on continuously. Accelerated electron gets collided with helium atom. Its energy is transferred to the helium atom. Helium atom goes to the metastable state. The excited helium atom gets collided with the neon atom, and then helium atom's energy is transferred to the neon atom. Neon atom goes to the excited state, and the electron which was at rest is again accelerated by the electric field, and then this process goes on continuously, and population inversion is achieved. What do you mean by population inversion? Hope you know it's the definition. The number of electrons in the higher energy level is greater than that, then the lower energy level is known as population inversion. This is the very important point for the production of laser. Without population inversion, you cannot get the laser light. Okay, look, now what happens after the population inversion is achieved? The laser photon is produced. Okay, due to the transition between what? Let me go there again in the energy level diagram, through which you can look. This when the electron jumps from 5s to 3p, laser photon is produced. Okay, this photon's wavelength is 632.8 nanometer, and this photon undergoes multiple reflection. Look here, this because of reflective mirrors. Because of these two reflective mirrors, that laser photon undergoes the multiple reflection, and it influences other excited atom to de-excite. And what happens? Too many, like there amplification of photon by stimulated emission is achieved. That is another important point for the laser light. And since the mirror M2 is partially reflective, means almost 5% of total photons are transmitted through it as a laser beam, and remaining are reflected into the that mixture of air, so that they will again de-excite the excited atom, helium, excited neon atoms, and laser light. That will be the continuous supply of the laser light. Okay, this much. And then so look, from this 3p to twice as, there will be the spontaneous emission. These photons are not desired, and almost this spontaneous photon, they escape from the sides of the tube, because this sides are caught at Brewster angle, Brewster, B-R-E-W-S-T-E-R, Brewster angle, and then now the accelerated neon atom gets collided with the wall of the tube, and this extra energy is transferred to the wall, and the radiation less transition takes place, and neon atom comes to the ground state, and then same process repeats, and we'll get the laser light. Since the mirror M2 is partially reflective, and we get the laser light through it. Let me repeat briefly, okay, one time. It is little bit lengthy, so please be okay, very serious, and it is very important. It's very important long question. Working of helium neon laser is generally asked in your long question, and you have to write first is diagram, energy level diagram, and working. Okay, and then first construction. So you must make the diagram, and then let me go to the construction. This construction, and you must make a simple paragraph on it. Okay, so short paragraph, and you should start in this way. And this figure shows simple experimental arrangement of what? Helium neon laser. It consists of a uniform bore glass tube T, which contains a mixture of helium and neon in the ratio of 4:1, 5:1, 9:1, 12:1, 15:1. Anyone you can pick up. You can pick up 9:1. Depending on the power, the ratio of the gases varies. There are two mirrors, M1 and M2, at the ends of the tube. The mirror M1 is 100%, almost 100% reflective, and mirror M2 is almost 95% reflective, and laser beam is emitted through it. There are two terminals to maintain the electric field, to maintain an electric field in the gas. This much is enough for the construction. Okay, so hope you understood. Simple diagram of helium neon laser, and which contains a what? Uniform bore, glass tube T, BURE bore, right? Bore means uniform. In the inner part will be uniform. That is called bore. Uniform BURE bore glass tube T, which contains a mixture of helium and neon. Okay, in the ratio of 5:1, 9:1, at reduced pressure. Be careful, and generally don't make mistake on that ratio of the gas, because helium must be at higher value and neon must be at less value. So helium will be 5, neon will be 1, or helium will be 9, and so and neon will be 1, like that. Let me repeat again. The ratio will be, and the ratio will be 5:1. Ratio of helium and neon will be 5:1, 9:1, 12:1, 15:1. Okay, and then there are two electrodes to maintain the electric field in the gas, and mirror M1 is 100% reflective, and M2 is 95% reflective, and laser light or laser beam is emitted through it. Okay, this is construction, one paragraph only. And then energy level diagram, you should write energy level diagram. The figure shows the relevant energy level diagram of helium and neon. Okay, helium atom. This is the energy level of helium atom. And it has metastable state twice as 2s metastable state having energy 20.61 eV, and which is nearly equal to 20.66 electron volt of neon atom. And it is 5s state. It has another important energy level 3p having energy 18.70, and lasing action takes place only between these two energy levels, and laser light of wavelength 632.8 nanometer is obtained, or in terms of angstrom you should say 6,328 angstrom, which is red laser, red light's wavelength. Okay, and this must work for the energy level diagram. Figure shows what relevant energy level diagram. It has low helium atom has metastable state twice as having energy 20.61 eV, and neon atom has energy level of 20.66 eV, which is 5s state, and it has another very important energy level 3p of having energy 18.70 eV, and laser light lasing action takes place between these two energy levels, and laser light is emitted through it. Laser light of wavelength 632.8 nanometer is produced. Okay, the next one is working. When the electric field is switched on, what happens? The electron is accelerated. Electron is accelerated by the electric field. Accelerated electron gets collided with the helium atom. Okay, because ratio of helium is higher, and the energy of electron is transferred to the helium atom, and helium atom goes to the metastable state by twice as, and the electron comes at rest, and which is again accelerated by the electric field. And then you can see here this accelerated electron gets collided with helium atom, and its energy is transferred to the helium atom, and helium atom goes to the metastable state twice as, and electron comes at rest, which is again accelerated by the electric field. Now what happens? The excited helium atom gets collided with normal neon atom, and helium atom's energy is transferred to the neon atom, and neon atom goes to the excited state 5s, which is also metastable state, and helium atom comes to the ground state. Now population inversion is achieved, and lasing photon is produced due to the transition of electron between 3p, 5s and 3p, and this photon undergoes multiple reflection between the mirrors, and photons are produced, and this due to the multiple reflection, this photon influences the other excited atom to de-excite, and amplification of light or amplification of photon is achieved, which is another very important point. Since the mirror M2 is partially reflective, and laser light is emitted through it. Okay, and then what happens? Now this electron is the neon atom is still in the excited state. This excited neon atom undergoes the transition of 3p to twice s, and 3p to 3s, and this will be spontaneous radiation. That's a spontaneous photon escape through the sides of the tube, and that excited helium atom again gets collided with the wall of the tube and comes to the ground state, and this process again repeats.